Hello everyone, welcome back to Nated Engineering. We are doing Forces Engineering Science N3, and we're going to start this topic by looking at three terms. The first one being equilibrium. What is equilibrium? Equilibrium is a state where opposite forces are balanced, or it's a state in which opposite forces are balanced. Or we can define it and say, if a body remains at rest when a number of forces act on it, then these forces are in equilibrium. What do we mean by that? Let's say we are having a block and we have forces acting in that direction. We also have forces acting in that direction. But this block is not moving. That simply means that the forces to the right hand side are equals to the forces to the left hand side. Therefore, these forces are in equilibrium because they are equal. The sum of the forces going to the left are equals to the sum of the forces going to the right. We can see that because the block is not moving, whereas forces are being applied to it. That is equilibrium. We go to the next one, which is resultant. Resultant is a force that it's a single force that can replace two or more forces and still produce the same effect. Let's say we are having a block again, and we are having three forces being applied. Let's say we're having three people, person A, person B, and person C. They are all applying 10 newtons to the block. Let's say 30 newtons is what is required to move the block. Now the block is moving because 30 newtons is being applied by these three people. If we can get a single person that can say, I can apply that 30 newtons alone, we are going to say this, say it's D. If this is the force, this force is the resultant force of these three, because it's the force that we can replace these three with but still get the same effect, which is 30 newtons. Let's look at another scenario. We are having two forces applied on an object again. We have a force in that direction. We also have a force in that direction. This is force A. This is force B. We said resultant, it's a single force that can replace two or more forces and still produce the same effect. First, let's start with these forces. If we are pulling the block in that direction and in that direction, where will this block travel to? It will be going in that direction. Meaning, if we were to get one force that can replace these two forces, it must be applied in that manner. Meaning, this force is the resultant force of force A and force B. If we're given something like this, and now we are asked to calculate for the magnitude of what force of the resultant force, which is R, we have to complete the parallelogram. It will be something like this. Let's say this force ends here. for explaining purposes. Let me just erase this one. Force P is like that. What we are going to do is we have to complete the parallelogram, and we are going to say, let's name this and say it's the vertical component and this is the horizontal component. Why? Because this line is vertical, this one is vertical, and this line is horizontal. Therefore, we're going to say this vertical component, this horizontal component. And we know that this line will be equals to this line. It's also VC. We are having something like this. We're having a triangle, a right angle triangle. Therefore, to get the value of r, we can use the Pythagoras theorem. B squared plus a squared. Or we can just say r squared is equals to the horizontal component squared, that is a square, plus the vertical component squared. Therefore, the resultant is equals to the square root of the horizontal component squared plus the vertical component squared. This is how we will calculate for the resultant force of force A and force B, which is why whenever we are having a force that is applied to an object at an angle, we see that force, let's say we're having a block again, and we have a force that is applied at an angle to the ground. Let's say it's angle of theta. This is the ground. And we can see that relative to the ground, this force is at an angle. Let's say this is force F. That is why, as I was explaining, whenever we are having a force that is applied at an angle to the ground, we say that force will develop two components, which will be the vertical component and the horizontal component. It's because we know that the force that we are given is actually a resultant of two forces. So now whenever we're given this force, because we want to know the vertical impact and the horizontal impact, we cannot use this force as it is. We have to get the two original forces that caused the resultant force. That is why we go to the extent of finding the components, which is the vertical and the horizontal component. And to get the values of those components, we are going to use trig ratios. Again, complete the parallelogram. This is equals to this. From here, we can use trig ratios. Soccer, Toa. Let's use sine. Sine is opposite over adjacent. Which one is the opposite? VC. It's opposite over hypotenuse. Sorry. The hypotenuse is F because we are using this angle. This will be our F. Therefore, the value of the vertical component will be given by F sine theta. We use cos theta for the horizontal component. Cos is equal to adjacent. Adjacent is this, which is the horizontal component. Adjacent divided by hypotenuse. hypotenuse is F, and our horizontal component will be given by F cos theta. So whenever you are given a force at an angle, before performing calculations, you will have to get the horizontal component and the vertical component. And you can use these formulas. Every time when you want to get the vertical component, you can use this formula. Every time when you want to get the horizontal component, you can use this formula. Meaning, for vertical, you can use the force that you are given, sine theta. For horizontal, the force that you are given, cos theta. But there is a condition. For you to always use these formulas, you need to always use the angle which the force makes with the horizontal plane. Meaning, if you are having a force being applied, you need to use this angle. If you are having a force being applied in this direction, you need to use this angle. Because this is the angle that the force makes with the horizontal. This is the horizontal that I'm talking about. If they can give you a equation like this, where they are giving you this angle, you have to say 90 minus that angle that they are giving to you and get this. Because this is the force that you have to use. This is the angle that you have to use always for horizontal component to be cos theta and vertical component to be sine theta. Once you use this angle, you then have to draw the triangle again and find the formulas using the trig ratios. This is not wrong, but I advise that you always use this. It's nice to have a standard equation, knowing that all your vertical components are associated with sine theta, or you're using sine theta for them, and all the horizontal components, you are using cos theta for them. It's easy to notice even when you are doing a mistake, because you know that once it's sine, it has to be a vertical. And don't forget, use the angle that the force is making with the horizontal. And then there is another issue, the issue of direction of the components. It's easy to spot the direction of a component, because you know, if we are having a force that is in that direction, that force is a resultant of what? Of a force going in that direction and the force going in that direction. But if maybe you fail for some reason to do it like this, you must remember that if the original force, which is this one, not the original force, the resultant rather, if the resultant is, let's say this, it's the block, or it's the point which we are working with. If the resultant is pointing away from this point, also the components, which is the horizontal component and the vertical component, will be pointing away. If we were having a force pointing towards the point, therefore your horizontal component and vertical component will be pointing towards. This is important for the direction of the forces, because we know a Cartesian plate is like this. This is positive and this is negative. What does this mean? It means that if a force is going up, that force is positive. If a force is going to the right hand side, that force is positive. If a force is going to the left, it's negative, and if a force is going down, it's negative. This will affect you when you are trying to calculate for the sum of the horizontal components. If you're given many forces and you're asked to calculate for the total vertical component, or the value of the total vertical component, so you have to consider the force, the direction of the components. You have to get the correct one. If you can't spot them right away, you can use the technique that I'm giving to you. But you have to remember, we are dealing with a Cartesian plate here. So when you are finding the directions, if you are in this quadrant, let's say your resultant force or the force that you're dealing with is in this quadrant, your component must be the wall of this component, of this quadrant rather. What do I mean by that? If you're in this quadrant, your component will be here. You say this thing is pointing away from this point, therefore this component will point away and this component will point away. What I'm trying to avoid is that you will be dealing with a force like this, and then someone come and say, you said when this force is pointing away from this, when the force is pointing away from the point, then the components will also be pointing away from the point. You see, now you are misquoting me, and this is wrong. This is the correct one. You see, the force is in the same quadrant as this one. The vertical component is going up and the horizontal component is going to the right. It will be positive. If you do it like this, the vertical component is going down and the horizontal component is going to the left. It will be negative, and this is wrong. So you have to always use the walls of the quadrant that the force that you're working with is in. If this is the force that you're working with, you don't go beyond these things. These are your components. It's pointing away, so that you get the correct directions, because once you get the directions wrong, your answer will be incorrect. And we're going to look at the last term, which is equilibrant. Equilibrant of a system of forces in the same plane is that single force which will balance the system of forces, or we can say is the force that will balance the resultant force. So if we are having a system of forces in that direction, object to move in that direction, the single force that will balance these forces is called the equilibrant. The equilibrant is the force that will bring this object to equilibrium. So you can say it's a force equilibrant of a system of forces is in the same plane is a single force which will balance the system of forces, or you can just say it's the force that will balance the resultant force. And that is how we conclude our first part of the forces topic. On the next video, we are going to do roof trusses or simple frames. I will see you on the next one.